Hello everybody. I want to take a minute to revisit the idea of a measure of central tendency, and I want to do that by looking at this particular problem on my math lab. Okay, so let me explain the setup for the problem. There are three car companies testing cars A, B, and C for their fuel efficiency, their gas mileage. And what would normally be done is they would run several tests, get different gas mileage values, and average those numbers together. That's how it would work, okay? But the word average is vague. Average can mean lots of different things. It could mean, I guess, any of the measures of central tendency, which are the mean, the median, and the mode. So what's happened here is manufacturer of car A says, well, we tested it one time, we got 28 miles per gallon. Then we ran the test again, we got 33 miles a gallon. So and they completed that test 5 times. Same thing happened with car B and car C. Now, understandably, the manufacturer of any of these cars wants to say that their car has the best fuel efficiency, okay? But the way they're going to summarize and say what the fuel efficiency is, let's assume, is by giving an average. They're going to give a number that is a measure of central tendency. They're going to give either the mean, the median, or the mode. So they might say our car had a mean fuel efficiency of whatever, or a median fuel efficiency of whatever. And maybe they'll give a number that's in their favor, okay? Now, before we work that problem, because I am talking about this, quick summary of what measures of central tendency are. So let's think of like this cloud here is just the data. These are the numbers. So we ran this test several times. We got all these numbers. That's the data, all right? And those numbers exist on the number lines. You might imagine they're all spread out or wherever they are, you know. So for example, this one's got 28 and 33 and another 28 and so on. And then they're all just kind of like strewn about the number line, okay? We call the mean, median, and mode measures of central tendency because they tell you about where this cloud of data is. Roughly, they point to the middle of it. So instead of saying like, well, there's this data all over the place, we say, well, it's right here, okay? That's what the central tendency number does. Now, probably, I mean, this won't always happen, but probably the mean will be a different number than the median and the mode. Okay, they're not all three going to be the same number, most probably. Okay, occasionally two of them might be the same, but let's go into this expecting that they could all be different. All right, now if you want to summarize your data by giving one number that says here's where the data are, that's what a measure of central tendency would do, and you've got 3 to choose from, then which one would you choose? Would you choose the one that seems the most accurate, that represents the data the best? Would you choose the most honest one, or would you choose the most dishonest one? Because assuming that they're different numbers, we could have some variation in how we want to present it. I mean, I hope we wouldn't be dishonest, but it is possible to be dishonest with statistics for sure. So let's do this. Let's go through and make these calculations and just see how they compare. All right. So I'm going to start with car A. Okay, so car A wants to give an average. Now again, average is a generic term. By that I might mean the mean, median, or the mode, to suggest that their car has the best miles per gallon. Okay, all right, so let's calculate each one of those measures of central tendency for car A. So here's the data for car A. 28 miles per gallon on the first test, 33 on the second, and so on. Now, the mode is the most common value in the data set. And I see in this data set, I have 2 28s, and every other number is unique. So the mode is 28. So we could say that the mode, miles per gallon, is 28 miles per gallon. The median is a number such that if you were to sort the data from smallest to greatest, and here I've done that, 28 being the smallest number, going up to another 28, then a 29, then 33, 36, sorted least to greatest. The median is the number in the middle, where half lie below it and half above it. So, and with the number 29, there's 2 numbers in the data set below it and 2 numbers above it. That makes 29 the median. So the car company A could honestly say, our car has a median gas mileage of 29 miles per gallon. Okay? Last, the mean. Here's how you calculate the mean. You add all the values in the sample and you divide by the sample size. So we had all these numbers which are in our data. Okay? 28, 33, 28, 29, 36. And those are 5 numbers, so we divide by 5 and we get 30.8 miles per gallon. So that car company A could suggest that our car has a mean gas mileage of 30.8 miles per gallon. Now, I used the same data to calculate all of these. You know, I looked at exactly the same number. You calculate them all differently, but they use the same numbers. Okay? But this one looks the best. Like, I mean, at least compared to these two. All right. Now, but let's look at it a little further. I guess what the company that makes car A wants to do is they want to give a number that makes it look better than the car company for B and for C. So like on a apples to apples comparison. And what I mean by that is the mode gas mileage for car A better than the mode for C and the mode for B? Or is the median gas mileage for car A better than the median for B or C, or what is it? All right, so what I've done is I've calculated all of those measures of central tendency for the other cars. So for car B, it's got a mode of 33, a median of 33, and a mean of 30.6. Okay, all right, and I calculated these the same way as I did for car A. Same formulas and everything. And for car C, I got a mode of 34, a median of 32, and a mean of 30.6. Okay, so let's look at it like this. Okay, here's all my numbers. Let me see if I can fit them all on here together. Here's the comparison that we want to make. All right. All right. So here's car A. All right, and it has a mode of 28, but that doesn't come anywhere close to beating the mode of 33 for car B. It's got a median of 29, but that doesn't come anywhere close to beating the median of 33 for car B or for car C. Okay, so it looks like the mode and the median really don't compare very well between car A, car B, and car C. But what about the mean? All right, the mean was 30.8. What is it for car B? 30.6. Okay, so the mean fuel economy for car A is 30.8. Well, so far that beats the mean for car B. What about car C? Oh, it was also 30.6. 30.8 is better. So if the manufacturer for car A wanted to give one of these measures of central tendency to make it look better, apples to apples comparison, comparing the modes, the medians, or the means, the mean would be it. It could say, our car has a mean gas mileage of 30.8 miles per gallon, but our competitor's car B, whatever that is, only has a mean of 30.6, and car C also only has a mean of 30.6. And as far as that's concerned, we're better. We've got the higher fuel efficiency. Okay, so that's the comparison that is intended behind this question. All right, the mean should be used since car A's mean of 30.8 is the highest mean of all 3 of these. All right. Okay, we compared all 3 of the modes, we compared all 3 of the medians, and we compared all 3 of the means, and that's where car A came out ahead. I'll leave it to you to try to do this next part. Okay. How would car B compare favorably against A or C? You know, in the same manner, should we use the median, the mean, or the mode? Okay. Or what if they were all equal and none of them showed that one was better than the other?